Welcome to the Xpediter TSO Additional Features module. Here you will learn about Xpediter testing features that are powerful, yet easy to use, and extend the basic testing capabilities covered in other modules. The additional features reviewed in this module are the Enhanced Find, which provides significant analysis capabilities, examining array contents, using extended capabilities of the peek command, the trace facility, which monitors and logs logic flow during program execution, and inserting commands, which allows evaluation of different source code fixes prior to making a permanent change. We will begin with the Enhanced Find. In the first example, we review, for comparison purposes, finding any string. Here we use perform. The result is similar to what would be seen in browsing a file. There is a found confirmation message, the text is highlighted, and the cursor is placed at the beginning of the string. Now we will look at finding a data element. The find command looks similar, but the result is very different. The confirmation message shows that the data element was found 5 times, once where it was defined, twice where it was used, and twice where its value was modified. In addition to the highlighted text and cursor positioning, the line is tagged with usage information. Also, def, use, and mod may be used as find parameters to limit the result of the search. Here we add the mod parameter, and here we see the result, the confirmation message, the 2 locations, and the usage tags. In this example, we add the exclude parameter, and we see that lines that do not contain the variable have been excluded from the display. Next, we add the no lines parameter, and we see that the message lines have been eliminated from the display as well. Next, for a point of reference, we go back to a find variable command. Here is the result. Note the data references count 4. Next, we add the alias parameter. This causes the search to include other data names referring to the same storage location, such as redefines or group-level variables. Here we see the result. The data references count is now 18. Let's look at the one modification usage. We specify the find command using both the alias and mod parameters. Here we see the result. The variable is modified by a read statement. In this example, we look at the find indirect command, which indicates at each entry of the command the data name in all possible places a data value is passed to or from the data name. We have turned off the keep window and used the exclude and no lines parameters along with the indirect parameter. The result of this command is shown here. Although the result of the initial find is the same as it would be for a simple find, the indirect parameter has set up the ability to use the find indirect processing. The next level of indirection may be viewed by repeating the find indirect command seen here. This command is the default value for function key 17. Here we see the result. We see the first of several related variables and where it is related. Another find indirect reveals another related variable. Scrolling down, we see how this second variable is related to the first. Subsequent indirect finds reveal numerous additional relationships until the end is reached. The original find indirect command, shown here, initially revealed 4 references. For a more far-reaching analysis, aliases may be included. Here we have added the alias parameter, revealing 18 references. Subsequent indirect finds would include aliases as well. For the final example of the enhanced find, we look at searching for statements relating to program input and output. Here we use the find command with the keyword input. The result shows the confirmation message and the read statement is highlighted. Next, we use the general I/O parameter and the exclude and no lines parameters shown previously. We see that 43 occurrences were found. A write appears first. Scrolling down, we see that open, accept, close, and display statements are included as well. Now we will look at examining array contents using the peek command. In this example, we have run a program to completion which has populated an array. We put the peek command at the structure level. Here we see the result. The array is treated as a long string of characters with a columns ruler above the data. The more indicator informs us that the data area is scrollable using the dleft and dwight commands, normally assigned to function keys 22 and 23 respectively. Scrolling to the right shows a change in the data and the columns ruler. Next, we have deleted the previous peek command and we enter another, this time at a subordinate data element. While we still see the scrollable data and the columns ruler, the subscripts appear as well. To access any element of the array, simply overtype a subscript. Here we overtype the 1 with 2, then press enter. The data of the corresponding element appears below the columns ruler. In some cases, it may be beneficial to walk through an array. Any of the subscripts may be written with increments as shown here. The subscripts are changed automatically by pressing enter, saving the need to change them manually. Other examples are shown. Here we will walk through the first 4 rows of the array. Now for the trace facility. First, we set the delay, which is how long each traced item pauses on the screen before proceeding. Here we have set the delay for 1.2 seconds. Next, we set a trace for all paragraph names. Then we enter a go command. Since we are tracing all paragraphs, the highlighted paragraph names appear as each is executed until we reach the default breakpoint. We could have gone beyond 25 by adding the max parameter to the trace command. An example is shown here. Next, we look at the log to view the trace. We see that each paragraph traced carries the module name and line number as well. Let's compare the trace from the original command with 2 others. Here we have added the modules parameter to the trace command. We see that subroutine calls are added to the trace result. In this case, we have displayed the source and set the trace for each module. The trace result now includes paragraphs within the subroutines. These examples all show paragraphs entered. To review every statement executed within those paragraphs, use Trace All State. Next, we will look at how inserting commands can be used as an additional testing tool. In this example, a program has crashed because of invalid packed data. The source of the data has been identified as a read statement. We would like to trap the bad data and change it before it is used. At line 630, the insert 3 line command is entered. These Xpediter commands look similar to COBOL code. If bad data is found for type H employees, we change it to a numeric value. The end if is required to terminate the Xpediter if. Pressing enter changes the entry to uppercase and does syntax checking. Errors would appear highlighted in a different color, and a message would appear near the top of the screen. The next steps, exiting from the testing session, then editing and saving the script, are not shown. The final script is shown here. Note that insert 630 is based on where the commands were inserted, but the end insert was generated by Xpediter. The member name containing this command set is bypass. A few words of caution are due here. If line numbers change with a program recompile, inserted commands may not work properly and may not work at all. Next, we launch a test and specify bypass for the initial script. We then locate line 630 to see if the commands are there. We see that the commands are in place. Note the absence of line numbers, which are used to set breakpoints. With inserted commands, a breakpoint may be set by using pause. An example is shown. A go command is entered, and the program runs to completion successfully. Note that while scripts are not required to insert commands, using an initial script allows using the retest command without losing commands inserted manually. For more information, the user's guides and reference manual are available on Frontline. This concludes this module. Thank you.